This video is over lesson 66, ratio problems involving totals, and it's for my 7th grade math class. In lesson 53, we learned about ratio word problems. To help us organize information from these problems, we use a ratio box. Ratio boxes allow us to easily write proportions, which we can then solve. So, ladies and gentlemen, ratio boxes are just a really great tool for organizing information. To be honest, when I'm working on problems involving things that are proportional, I still think out a ratio box. I don't always write it out, but I still think it out. It's just very helpful to get everything in the right place. Remember also that a proportion is a statement that two ratios are equal. So essentially it's going to look like two equal fractions, because we'll write the ratios as fractions. So just to review, we always label the first column of our ratio box ratio, the second column is actual, and then depending on what ratio we're looking at, we name the groups appropriately. So group 1, group 2 are in red here because we would replace them with words. So if we were looking at a girl to boy ratio, then group 1 would be girls, group 2 would be boys, and then so on and so on. So for our purposes here, I went ahead and filled in some letters. So let's say that the ratio number for group 1 is A, the ratio number for group 2 is C. The actual number of group 1 is B, and the actual number of group 2 is D. Well, once I've got it organized in my ratio box, then we can just turn it into a proportion by putting A over C and B over D. Well, today we're going to be taking our ratio box and we're going to be extending it. So in ratio word problems involving totals, it can be helpful to add a third row to our ratio box labeled total. And so you'll see that right here. There's my traditional ratio box right there, the first two rows. And then the third row, notice that that's in black because that's something you're always going to write. That third row will always be total. And total is real simple. Total, we're just going to total things up. So if that's the ratio number A, this is the ratio number C, then this is just going to be whatever those two add up to. Likewise, if I know my actual numbers, I can just add them up to find the total. Or if we were to reverse this, of course, if we know the total and we know one of the numbers, we could subtract to find the other. So here's my box, my extended box. The thing though is if we go back to the original had two rows and two columns, which very easily turned into two fractions. So the first row became the numerators, second row was the denominators, first column is one fraction, second column is another fraction. Well, down here, I've got three rows, but two columns. So that means we have one too many rows. So notice that our proportion, though, only requires two rows and two columns. Thus, to write a proportion from the ratio box, we will ignore one row. We've got too many rows, just ignore one. So there are actually three different rows that we could ignore, meaning there are three different proportions that we can make out of this. So we're going to take a look at all three quickly here. So first of all, let's say we ignore group 1. So I'm going to use my red pen here just to cover up group 1. So if I ignore group 1, my proportion is going to be C over A plus C. So C over A plus C equals, equals D over B plus D. And that's it. That's my first proportion. To make my second one, we're going to ignore group 2. So then this will be A over A plus C. And then the second fraction here will be B over B plus D. And then finally, our third proportion is going to come from ignoring the total row, which means it's actually going to look just like our proportion did up here. I'll have A over C and B over D. Now, when you're working out problems, you're not going to need all three of these. We're going to do some examples together where we'll talk about how to choose which row to ignore and which ones to use in your proportion. So let's talk about that right now. So choosing rows. There are two things we need to consider in order to figure out which two rows to use. First, we only want one unknown. So we want to ignore one of the rows with a variable in it. So typically you're going to have two variables in your extended ratio box. You don't want to use both of those rows. Okay, just one of them. Second, we do not want to ignore the row with a variable that will allow us to solve for the answer of the question. So we want to use the one that's going to answer the question. That's the variable we want. So we're going to choose the row that has all numbers, and that will keep us from having two variables. So if we choose the row that has all numbers, then we know there's only going to be one variable. And we want to choose the row that will allow us to solve the problem. Choose the row that has all the numbers. Choose the row that will allow us to solve the problem. All right, ladies and gentlemen, we're going to do some practice problems together. But what I need you to do is I need you to please grab your books, and I need you to open up to page 400 and I believe it's 68. 468. It should be the practice problems for lesson 66. So go ahead and pause the video while you do that. All right, and here on the back, I've already got it mostly set up for you. Keep in mind that all the boxes and everything else like that, everything that's in black here, you would need to do on your homework yourself. So you would need to actually make this box and everything. The gray lines, those would just be lines on your paper. The red, you don't have to have. You don't have to have the red. So problem A. First of all, directions. Solve these problems. Begin by drawing a ratio box. So we know this is going to be a ratio problem. I don't even have to read the problem, and I already know that this is going to be ratio. This is going to be actual. I know that this is going to be total. Now to find everything else, we got to read. So problem A. The bicycle store has mountain bikes and racing bikes on the showroom floor at a ratio of 3 to 5. If there are a total of 72 bicycles on the showroom floor, how can you find the number of racing bikes? Use your method to find the answer. I'm not going to worry so much about saying how to find it. We're just going to go ahead and practice finding it. So look at the ratio. We have a 3 to 5 ratio. So what does that 3 represent? What does that 5 represent? So the first thing mentioned was mountain bikes. So when I go to fill this out, I'm going to give enough details that somebody looking at this and looking at the problem should be able to figure out what I'm talking about. So I'm just going to say mountain. I know it's mountain bikes. The second number in the ratio has to do with racing bikes. So it's mountain bikes to racing bikes. Now let's fill in the numbers. So what was the ratio number for mountain bikes? Well, it was 3. What was the ratio number for the racing bikes? That was 5. Well, 3 and 5 now makes a total of 8. So we're not going to actually write 3 plus 5. We'll just go ahead and answer it. It's 8. Okay. Now, read through the problem carefully. What was the actual number of mountain bikes the problem said we had? Well, it didn't say, so I'm going to put an X there. What was the actual number of racing bikes it said were there? Well, again, it didn't say. I'm going to make that Y. What was the actual total of bikes? It said there were 72. So that's my ratio box. Now, I need to consider which 2 rows am I going to use for my proportion. So remember, the first thing we choose is the row that has all numbers. That'll keep me from having 2 variables. So that means we definitely want to use the total row. Now look at the question. What's the question asking for? So it's asking, how could you find the number of racing bikes? So I want to know the number of racing bikes, which means if those are the 2 that I'm using, that means the one that I'm ignoring then is the mountain bikes. And now we can make our proportion. So my first fraction will be 5/8. And my second will be y/72. Just take them right in order, guys. Make sure you've got your fraction bars. Make sure you got your equal signs. I provided them for you this time. You'll have to provide it yourself in the homework. Now, to solve a proportion, remember the first step here is we cross multiply. So 8 and y are across from each other. And we always write that 8y, not y8. 8y number first. And this should be equal then to the other cross product, which is 5 times 72. So remember, first step is to cross multiply. I think that deserves an exclamation point. Cross multiply. Now to solve this, we want to get rid of that 8 so that y will be all by itself. So I'm going to divide both sides by 8. And so my 8 that I'm multiplying by and the 8 that I'm dividing by will cancel out. That leaves me with just y. That's perfect. That's what I want. On the other side, notice that we got multiplication here, so we can reduce before multiplying. So I'm going to reduce my 8 and my 72 because I realize 8 goes into both of those. 8 goes into itself once. 8 goes into 72 9 times. With a 1 in the denominator, that means that my answer will be a whole number. So 5 times 9 is 45. Now consider, where did y come from? Y came from racing bikes. So my label is 45 racing bikes. Now, if you're feeling pretty good with that, I would say go ahead and pause the video, and you can do B and then hit play again and see how you did. And then you can do likewise with letter C if you're feeling comfortable. So give yourself a little bit of challenge. Go ahead and give that a shot. So I'm going to pause just for a second to let you hit pause, and then I'll start going into my explanation. All right, B. The recycling club collects cans and bottles for recycling. The ratio of cans to bottles collected was 8:9. If they collected 240 cans, how many items to be recycled did they collect in all? All right, so ratio, actual, total. Those are always on there. Now let's go ahead and fill in what are my two things in my ratio. So the ratio is 8:9. 8 had to do with the number of cans, and 9 had to do with the number of bottles, which makes a total ratio number of items 17. And then we were told that if they collected 240 cans, so we know we actually have 240 cans, but we're not told how many bottles, and we're not told how many total items. So once again, we want to choose the two rows that we talked about on the front of the page. We want to choose the row where we know everything, so we're going to choose the can row, and we want to choose the row that's going to tell us what the question is asking. So the question is asking for the total number of items. That will be right there. So I'm going to ignore the bottle row. If I can get that on there so we can see. So my ratio is going to be 8/17. And that's going to equal 240 over y. Just as we did before, we're going to cross multiply. We like to have our variable on the left side of the equal sign, so I'm going to start with the cross product that has the variable in it. So we're going to have an 8y again. And on the other side, 17 and 240 are across from each other. Well, since we have an 8y just like last time, we're going to divide both sides by 8 again. So the 8 that we're multiplying by and the 8 that we're divided by will cancel. That will leave me with just y. Over here, I realize that 8 and 240 can reduce. 8 goes into itself once. Now, if 8 goes into 24 3 times, then it will go into 240 30 times. Now, if you've got 17 times 3 memorized, you should have this answer pretty quickly. If not, work it out. So I do have it memorized. I've seen it enough times in the course of my life. So 17 times 3 is 51. So times 30 would be 510. Remember, this is y, so y is the total. Okay, well, if you got cans and bottles, let's look back at the problem. The problem describes this as how many items. So my label will be items. There are 510 items total. And finally, letter C. The ratio of big fish to little fish in the pond was 4 to 11. If there were 1,320 fish in the pond, how many big fish were there? So, ratio, actual, and total. Our ratio there is 4 to 11, and so the 4 has to do with the big fish, and the 11 has to do with the little fish. So 4 is the ratio number for the big fish, and 11 is the ratio number for the little fish, which makes a total ratio number of 15 for all of the fish together. Oh, sorry, I was down there a little too far. Pause there to let you get it. All right. So let's see what else the problem says. The problem also tells us that there were 1,320 fish in the pond. So that is a total number of fish, 1,320 fish total in the pond, which means I don't know the actual number, and I don't know the actual number of the big fish, and I don't know the actual number of the little fish. So choosing my 2 rows, first I'm going to choose the row where I know all the numbers. So that way we will only have one variable. And then I'm going to choose the one that's going to answer the question. So the question is wondering how many big fish were there. So I want to know the top row again. So that means, once again, like last time, we're going to ignore that middle row. So my ratio will be 4 over 15 equals x over 1,320. And we'll go ahead and cross multiply here. So this time, x is across from 15, so we'll have 15x. And then we'll have 4 times 1,320. So if we divide both sides by 15, then 15 that I'm multiplying by will cancel with the 15 I'm dividing by. That'll leave me with just x. On the other side here, if I take a look at this, I actually see that 3 goes into this and 3 goes into 15. And the reason I see that is the divisibility test for 3. If you add up all the digits of this number, so 1 plus 3 is 4, plus 2 is 6, plus 0 is still 6. If you can divide 6 by 3, then you can divide the original by 3. So I know 3 goes into 15 5 times. So if I think about it here, 3 would go into 13 4 times with 1 left over, so a little short division there. And then 3 would go into 12 4 times again with nothing left over. And then 3 would go into 0, well, 0 times. So it must be 440. And well, that ends in a 0. Things that end in 0 can be divided by 5. So if I reduce this now by 5, 5 goes into itself once. And then 5 would go into 44 8 times with 4 left over. And then 8 would go into 40 8 times perfectly, 88. And so I'm going to keep trying to do this as mental math. With a 1 on the bottom, that means it's going to be a whole number again. So 4 times 88. Well, you know 4 times 8 is 32. So 4 times 80 is 320. And so if we just put those together, 352. Now x is in the big fish row, so this is going to be 352, big fish. And that, ladies and gentlemen, is the end of our lesson.